when it is applied on a destination IP address, it gives us the network address, right? So it helps us identifying the subnetwork IP address so that we can follow it to the relevant, correct uh, subnet, right? So how we calculate subnet mask? Obviously, it's the 32-bit number. Again, it has 4 octets, just like an IP address. So what we do basically is, as a number one step, you can say, what we do is we express the subnet IP address in binary form. So whatever is your subnet IP address, we express it in the binary form, and then we replace, as step 2, we replace the network bits, all the bits in the network portion with 1. So we set all the network portion bits, right? Okay. So we will also see this with the help of an example in a minute. The number 3 step is to replace all the host portion bits with 0. Right? So what we do, we represent the the IP address in binary form. We replace the network portion bits with all 1s, and we replace the host portion with all 0s, and then again we convert it back to dotted decimal number. Right? So this will be the subnet mask. Okay. See, we can also have some default subnet masks just to understand it, right? What do you think? What will be the default subnet mask of class A? So what was the rule? What are the steps that we just discussed? Right. So we know that there are 4 octets. And if I talk about class A, we know that the first octet represents the network portion, and the remaining octets represent the host portion. So as a first step, what I'm supposed to do, I will turn all the network bits 1. Right? So in order to calculate the subnet mask, as a first step, I have represented it into binary, and I will uh, represent all the network portion bits with 1. So if all the bits are set in an octet, what will be the highest value of the octet? Yes, you're right, 255. And as a second step, what I have to do, I have to replace all the host portion bits with zeros. So this means these host portion bits contains 0, all zeros. Right, and same is the case here. So what will be the default subnet mask of class A, where all the bits in the network portions are 1 and all the bits in the host portions are 0? So this means the default subnet mask is 255.0.0.0, as you can see here, right? So the default subnet mask of class A is 255.0.0.0. And how we have calculated it? Very simple. We have replaced all the network portion bits by 1 and all the host portion bits by 0. Similarly, we can calculate the default subnet mask of class class B. So again, we have 4 octets. And we know in class B, first 2 octets represents the network part, and the remaining 2 octets represents the host portion. So what I have to do is I have to turn all the network portion bits 1. So all 1s here means what in this first octet? Yes, 255. Again, all bits in the are 1 in the next octet representing this network part. Yes, 255. And all the bits in the source portions are 0. Again 0. So what will be the default subnet mask of class B? 255.255.0.0. And what about class C? Yes, in class C again, we know that first 3 octets represents the network part. So these octets represent the network part, and then we have the last octet representing the host portion. So if all the bits are set in the this octet means 1, we know its maximum value can be 255, again 255, and then again 255. And all the bits in the host portion are 0. This means 0. So what is the default subnet mask of class C? 255.255.255.0. So these are the default subnet masks when we are not borrowing any bits from the host portion, right? So if I will be borrowing some bits from the host portion, obviously there will be a change in the default subnet mask. So, but at the moment, these are the default subnet mask, easy to calculate. The subnet mask is a 32-bit number, and we calculate it by turning all the network portion bits 1 and turning all the host portion bits 0. Right? So this will give me the default subnet mask of class A as 255.0.0.0, default subnet mask of class B 255.255.0.0, and the default subnet mask of class C 255.255.255.0.